Alright guys, today we're going to continue on with our absolute value stuff, and we are still going to stick with some graphing, but now we're going to use graphing to actually help us solve an absolute value equation. So far we've worked with how to graph an absolute value equation. How to pick out if it stretches, shrinks, reflects, moves left and right, moves up and down. How do I figure out what the slope of that right side would be? How to get that V-shaped graph. Now we're going to use that knowledge to help us start solving absolute value equations. You guys have solved equations before, but they were all linear. They just had a plain old x in them. Not an x squared, not an absolute value of x, just plain old x. We've done a bunch of that. Now we need to start solving equations that involve absolute value. So to start off, we're going to do a little refresher, and we're going to graph a system of equations. We've spent a lot of time this trimester on systems of equations, systems of inequalities. To be a system, we just need to have two or more equations. That's all we need. So we're going to graph these one at a time. So the very first one, we have y equals the absolute value of x. Y equals absolute value of x. We cannot get any more basic than that. That graph does not stretch, reflect, left, right, up, down. It doesn't do anything special. That is our original graph. Vertex at 0, 0. Slope of the right is 1. And I'm just going to put a few points on there. There we go. Alright, so there is y equals the absolute value of x. That's equation number 1. Equation number 2 just says y equals 2. Equation number 2 just says y equals 2. What kind of line is that? How does that line look? When we just have the y equals, how does that line look? It's just, they're all straight lines when we graph a line. It's a horizontal line. Horizontal line right through y equals 2. Horizontal line right through y equals 2. So now the question is, we're solving a system. Where do I find my solutions at when I graph a system? Where the two graphs do what? Where they meet. Yeah, where they intersect. Now back when we graphed systems earlier this trimester, we just had two lines that intersected in one point. We listed that point and moved on. How many places does this intersect? 2. So that means we need 2 different places. So we've got, what do we have there? Negative 2, 2. And we have 2, 2. So when we're solving a system and it has absolute value, we end up with 2 solutions, not just one. We end up with 2 solutions. I guess I can connect that arrow up there. There we go. We end up with 2 solutions. We can check our solutions, same as we always have. The second equation we really don't need to check because it's just y equals 2, and that's what we have in both of ours is y equals 2. For that top equation, though, when we check, 2 goes in for y, negative 2 goes in for x. Is the absolute value of negative 2, is that 2? Yes. Yeah. It checks. And then we put the point 2, 2 in. We know the absolute value of 2 is 2. That one checks also. So really, only new idea right now is that we're going to have 2 solutions on this graph. We've graphed systems before. We've graphed absolute value before. We've graphed horizontal lines before, and we've found intersection points before. But we've never had one that had 2 solutions. We've had 1, we've had none, and we've had infinitely many, but we've never had 2. So let's try the second one. We have y equals 2 times the absolute value of x plus 1. So let's pick this apart, because I know on your quiz and your worksheets, when all we were doing was graphing absolute value, I gave you a whole bunch of little answer blanks to think about. Give you a whole bunch of little answer blanks to kind of prompt you through and think about, are we stretching? Are we reflecting? What's the slope? And things like that. But we need to start getting away from that piece and being able just to graph them without being prompted all the way through it. So let's take a look at that 2. The 2 is in front of the absolute value bars. What are some of the things that 2 tells me about my graph? What does it tell me? Okay, that's my slope of the right. Awesome. All right, slope of the right. What else does that 2 tell me? One more thing it tells me.
Positive.
It is positive. So no reflection. Okay, it's the slope of the right. There's no reflection. I like that. And what's the other thing that 2 tells me? It's bigger than 1, so what's my graph going to do? It's going to stretch. Which means, and you might be thinking, Miss Golly, what was the point of having to say if it stretches or not? That's how I know my graph should look skinnier. So when I graph it, if my graph's looking pretty flat, I know I made a mistake. All right, so that 2 out front tells me the slope of the right side. It's positive, so it's no reflection, which means it's going to open up and look like a V. And it's going to stretch, which means we're going to have a skinnier V. All right, so now take a second and think about this one. The plus 1 inside the bars. Which way do we go? We go left. We go left 1. The plus 1 inside the bars, it goes opposite of what we think it should. And I've got most of the way through grading your quizzes, and a lot of us are doing really, really well with that part. So slow yourselves down. All right, so now we've run out of numbers. We've run out of numbers, so we're ready to graph. We've gotten all the information we can out of this equation. We're ready to graph. We always start at 0, 0. We don't put a point there necessarily, but that's kind of our starting area. And we're going to go left 1, and we don't have an up or down. We're going to go left 1, we don't have an up or down. There's my vertex. There's where I'm going to start my graph. It's where the 2 sides of the V come together. We said the 2 out front was our slope. So we're going to do, if you want to put it over 1, you can if that helps. We're going to go up 2 and right 1, up 2 and right 1. Now, since we are looking for intersection points, maybe let's go up 2 and right 1 again, because we're not sure where that's going to intersect yet. To get the other side of your graph, I know some of you it really helped to draw that axis of symmetry in. I saw some of you draw it on your quiz, some of you didn't. It wasn't worth points. Some of you, I know it just helps you graph. That's okay. So we have the reflection over that line. Or however you choose to get that left side. I was seeing some really nice symmetric graphs on your quiz, so you guys all know how to get that left side. How you go about doing that, you've kind of found your own little way for that. All right, so that first one is graphed. We went to the left one, and we had a slope of 2. Our first equation is graphed. The second equation, again, we just have a y equals 4. Just like our y equals 2. Have that nice horizontal line through where y is 4. Nice horizontal line through where y is 4. Then just like when we graph systems that just had 2 lines, we look for the intersection points. Intersection points are our solutions. So we have -3, 4. And we have 1, 4. and we have 1, 4. So this idea, we're going to take what we've been doing with graphing absolute value, and we're going to take that idea of a system of equations, and we're going to use those two ideas that we're already super familiar with to help us solve absolute value equations. Okay, so lots of stuff we're already familiar with. So I want to go down to the bottom piece. It says solve the absolute value equation. It says graphically and algebraically. Today, we're going to be using this sheet for quite a few classes, guys. Today, we're just going to focus on the graphically part. Okay, we're just going to focus on that graphing piece today. Now, if you take a look at number 1, we have the absolute value of x plus 2 equals 3. How is this equation different from the ones we've been graphing? We've spent the last few classes graphing. We just graphed the first 2 today. How is this equation different from the ones we've been graphing?
There's like no y equals.
Yeah, there's no y equals. There's no y equals. Instead, we have a 3 equals. We don't have a y equals. So I can't just jump in and say, okay, I'm going to go left, or I'm going to go right, or I have a stretch, or I don't have a y equals. This one isn't just a, hey, graph it and move on in life. So what we can do, though, to solve this graphically is we want to try to figure out where the two sides are equal. So if we want to figure out where the two sides are equal, we can turn this equation into a system and figure out where they intersect. So all we have to do is take what's on the left side of the equal sign, take what's on the left, make it into an equation of y equals, take what's on the right, and make it into an equation of y equals. The idea of solving an equation is trying to figure out when does the left side equal the right side? When will the left side equal the right side? So if I set them up, the left side and right side, if I turn it into a system and we figure out where they intersect, we're going to know where the left equals the right. Let's see if it works. Okay, I don't want you to just like buy into it, be like, okay, Miss Golly, great. Let's see if it works. Let's graph these. Let's find where they intersect, and then let's check it and make sure it works. So let's take a look at our very top one, our absolute value one. Our absolute value, we just have a plus 2. We just have a plus 2. So we had talked about this yesterday before we quizzed, and a few of them were on your quiz. If there's no number out front, and you're thinking, well, so what's my slope? You can add a 1 in there. That's okay. You can add a 1 in there. So we can have, in this one, we have a slope of 1. Now, if you want to write down that there's not a reflection and there's not a stretch or shrink, you can write those things down if you want. Or you can just choose to write down the things that will happen. It's up to you. If it's helpful to you to write no reflection, no stretch, or shrink, you can do that. If that's helpful for you, please do that. If you want to write down every time those things, you sure can. The plus 2 inside the bars, I think we just did a plus inside. The plus 2 inside is going to make me go left 2. So this particular absolute value one, it just goes left 2. It doesn't go up or down at all. It doesn't stretch, doesn't reflect, doesn't shrink. All it does is move left 2. It's one of those basic ones. And then my slope is just 1. Now, since we're graphing a system, we don't know where it's going to intersect, so I'm going to make this V as long as I can. But I'm going to make it so it's not lopsided, though. There we go. I'm going to make this V as long as I can. Now, once you start solving more of these and you start catching on to what that y equals is going to look like every time, you're going to end up making these, drawing these a lot faster. So what we have is a y equals 3 for my other one. When it's just a y equals, we're going to get really good at the y equals equations by the end of this little unit. Y equals is just that nice horizontal line right through where y equals 3. Right through y equals 3. We look for our intersection points. We've got negative 5, 3. And we have 1, 3. Now, when we go to actually solve the equation, though, we talked about this before we even started graphing. Our original up here, our original has no y value. So when we find our intersection points, do we care about the y value? No. When we're solving this, we only need to worry about the x. There's no y in our equation. We're setting those up as y equals so we can graph them and figure out where the left side is going to equal the right side. But when it comes to actually solving, we have x equals negative 5. And if you want to, when you write this, you can just put a comma and then put the other one. It's not an ordered pair. There's 2 possible answers for x. We had 2 intersection points, so we have 2 solutions. We don't need the y because the y isn't part of our equation, just x. Very, very important part is that we check. Okay, I know a lot of you, based on, again, the quiz results I'm seeing, a lot of you are very comfortable graphing absolute value. But it's still possible, even if you aced your quiz, it's still possible that from time to time we make mistakes. We accidentally go right when it should be left. We accidentally go up 1 over 2 instead of up 2 over 1 for a slope of 2. It happens. We miss a reflection every now and then. So check your answers. So we have the equation, we have absolute value of x plus 2 equals 3. I'm going to start by checking negative 5. So negative 5 plus 2. We do what's inside the bars first. So negative 5 plus 2 is negative 3. Does the absolute value of negative 3 equal 3? Sure does. It checks. So here's the great part. We can still check our solutions. Like I said, guys, the quizzes with the graphing, it's looking fantastic. But even I know I made the answer key for some of the practice for this, and I know one time I totally overlooked a negative sign, and so I didn't reflect my graph. It happens. So just use this to double check. And yes, you should check both solutions. So I'm going to put a 1 in for my x. Absolute value of 3. Remember, guys, absolute value is just a distance. It doesn't mean I switch my sign. It means what's the distance from 0. So it's always going to come out to be positive. It's always going to come out to be positive. All right, I want to help you guys get started on number 2. Remember, the algebraic piece. Try to, if you can, try to keep your writing out of that algebraic piece, because that's going to be a few classes from now. And the reason why I put them on the same sheet is because I want you to be able to see that solving graphically and solving algebraically is going to give us the same result. And don't let the word algebraically freak you out. Algebraically just means how you solve when you use all those properties like your additive, inverse. So to undo addition, I use subtraction. To undo multiplication, I use division. Those types of things. So algebraically is how you're used to solving the equation without the graph. Okay? All right, so number 2, I just want to help you get it set up. Then I want to give you a chance to graph it. Give you some time to practice some of these today. We'll spend tomorrow practicing these too, getting you comfortable with these. All right, so I want to know, when does the left side equal the right side? One way for me to do that is to take the left side and graph it. Take the right side and graph it. So I want to go ahead and give you a chance to try graphing these, and then I will go through this one. But if you go through and graph it and you check it and yours checks, you can move on. I'm not going to slow you down. All right, so when we go to graph this one, and it's something that I'm hoping you kind of catch on to pretty quickly. When you have just y equals a number, whether it's listed first or second, the y equals one, I would always graph that one first. You know exactly what that's going to look like. That's going to be a straight line, a horizontal line, through whatever value the y is. So that's the one I would always start with, whether it's your first equation or your second equation, it doesn't matter. I would always start there because you know exactly what that graph is going to look like. And then it might save you from having to draw so many points on your absolute value graph. So I would always start with the horizontal line part first. All right, then with the absolute value one, we don't have a number in front of the bars, so if you need to write a 1 there, you can, to give you your slope. The plus 2, that was our newest piece of the graphing. We just did that a couple classes ago. The plus 2 is outside the bars, so we're going to go up 2. So the only thing that this graph does, it goes up 2, and then our slope is 1. Once your two graphs intersect, you don't have to keep drawing points on that absolute value. You can if you want, but you don't have to. So then we find our intersection points. We have -2, 4, and we have 2, 4. Again, we're looking to solve that initial equation. That initial equation only has x's in it. We put the y's in there so we could graph. So we only care about the x values. So we would have x equals -2. And if you want to put the comma there, you can. If you want to put the word or in there, if you want to put x equals in there twice, you can. Doesn't matter to me. So now make sure you check. So when we check, and it doesn't matter, guys, the order you write those in. If you put +2 and then -2, that's not an ordered pair. You could also write this x equals -2 or 2. You could write this x equals -2 and put another x equals and put a 2. It's not an ordered pair. It doesn't matter which solution you write first. It does not matter at all. So when we go to check, we put our solutions in one at a time. So -2 goes first. Absolute value of -2 is 2. Then 2 plus 2 is 4. Check our other one. So we put a 2 in. Absolute value of 2 is 2. And we do get 4 equals 4. We do get that piece. So make sure on these. Make sure, I know a lot of you are, again, you're getting really great at graphing absolute value. I know we can all graph a horizontal line. We can all find intersection points. Make sure you're taking the time to actually check. Like I said, I was making an answer key the other day. I totally skipped over a negative sign. My graph should have reflected. I didn't draw my graph right. And I've done a ton of these. So it's really easy to just maybe accidentally go down when you should have went up, or you went left instead of right. It's easy to do that. So again, the idea is we're taking what we already know. We know how to graph absolute value. We know how to graph a horizontal line. We know how to find intersection points with the system. We're taking those things to help us find an answer to an equation that we've never solved before. So the first two that we did here Pretty basic absolute value graphs. Pretty basic when it comes to the checking part too. So let's flip our sheet over. Let's crank it up just a little bit. I just want to make sure that the first few that we do are staying pretty basic for us. Our first graph just went left. Our second graph just went up. And actually I do have a couple more basic ones before we do crank it up a little bit today. And if you're thinking, Miss Golly, I think I got this, if you want to work ahead of me a little bit, you can. We're just going to finish up with these four today. Call it good for today, and we'll get a bunch of practice time tomorrow on these. Get a bunch of practice time. So when I take a look at number 3, again, don't worry about the algebraic part. Don't worry about the algebraic part. We're just focusing on the graph piece today, because that's what we know how to do. We know how to graph these. So I'm going to take that left side, I'm going to make it into an equation. I'm going to take the right and make it into an equation. When I do these, now that we know what we're looking for those intersection points, I always graph, whether it's listed first or second, guys, I always graph the y equals 1 first, because I know exactly what that's going to look like. And graphing that one first is just going to save me from potentially graphing a whole bunch of extra points on my absolute value graph that I don't need. So I'm going to go y equals -3. Then for my absolute value equation, all I have is a 2 out front. We know that number out front is the slope for us. It's the slope of the right side. Remember that. It's the slope of the right. And then it's positive, so I don't reflect. It is bigger than 1. So we are going to stretch, so I know my graph should look skinnier. That's why we pick that out. I know for some of you like, Miss Golly, I get that we should pick out if it's a reflection or not. I get we need the slope, but what's the point of telling if it stretches or shrinks? The stretch part tells me my V shape is going to be more narrow. It's going to be skinnier. It's not going to be a wider graph. So if I get that flatter, wider graph, I know I made a mistake graphing it. And that's really important for us to know, because all we're using to graph are shortcuts. We're not making tables and finding ordered pairs. We're using shortcuts. All right, so there's nothing inside the absolute value bars with the x, so we don't go left or right. There's nothing attached onto the end, so we don't go up or down at all. So we're just stuck at 0, 0 with a slope of 2. Well, I know some of you, I saw a few hands shooting up like, Miss Golly, did you make a mistake? I didn't make a mistake. This is something that can oftentimes happen with absolute value. Because can absolute value equal a negative number? Absolute value can't be negative, can it? Absolute value can't be negative because absolute value is a distance. So if I try to take the absolute value of 2 times the absolute value of x, if I try to get that to equal -3, it's not going to work. My 2 is positive. My 2 is positive. The absolute value of x is always going to be positive. So this right side is always going to be a positive times a positive. That right side's always going to be positive. The 2 is positive. Absolute value always comes out to be positive. Positive times a positive is always positive. This one is a no solution. That happens with absolute value more often than a lot of our other types of equations. Because absolute value, it always comes out to be positive, so it's really hard. It's really hard when it equals a negative. But now, having said that, let's look at number 4, because I don't want you to think that if you automatically see a negative here that it's, oh, see you later, no solution. This side's negative, which is true, but take a look over here. I'm multiplying by a negative this time. The 1/2 is negative. The absolute value of x is always going to be positive. So this left side is always going to be a negative times a positive. So it can equal a negative. Absolute value itself will always come out to be positive. But if I turn around and multiply it by a negative, that expression itself will be negative. So I don't want you to think just because you see a negative that it's automatically going to be no solution. It's not automatically going to be that. So let's go ahead and pull these apart. Negative 1/2 absolute value of x. And then we have y equals negative 2. I always graph the plain old y equals first. Again, it might save you graphing a few points. Might save you graphing a few points. I know some of you, you're working ahead of me. You've got your notes out. Go ahead. A lot of you are doing awesome on your quizzes, how far I've graded them. You know your stuff. Go ahead and graph it. I'm not going to slow you down. But if you're still feeling like, no, Miss Guy, I need you to talk me through where I get my slope and if it's a reflection or if it's a left-right, then stick with me. So when we pick apart that absolute value equation, that negative sign, we're going to have a reflection. And that's really important for us to know, because when I go to graph, if my graph isn't flipped upside down, I did something wrong graphing it. I made a mistake with my slope. Now the 1/2 piece, the 1/2 is what causes the shrink. When you're looking for a shrink or stretch, you don't worry about the negative sign. The stretch part is if the number's bigger than 1. The shrink part, I know some of us have shortcut that in our brain, and sometimes I say it too. The shrink part, sometimes we just end up saying, oh, the number's smaller than 1. Well, all negative numbers are smaller than 1. So when we look at the stretch and shrink, we're just looking at just that number value. The negative sign makes it reflect. The actual number piece without the sign is the stretch or shrink part. Then if I put the two together, my slope is a negative 1/2. So the negative sign gives me the reflection. The 1/2 gives me the shrink. The two together give me the slope. So this graph, just like we saw in number 3, it doesn't go left or right, it doesn't go up or down, so we're stuck at 0, 0. It does reflect. The slope's a negative, so my graph should be opening down. So we go down 1 and right 2. Down 1, right 2. Down 1, go to the left. However you like to get that left side of your graph, it's kind of up to you. Then we find where we intersect. Whoops, -4, -2. Here we go. And remember, we only care about, we just need the x values. Because really, we're not solving a system, we're solving just a single equation. To solve it, we ended up graphing each side. We turned it into a system. And then so important, so very important that we check. We've got x equals -4 and 4. It's so important that we check. Now these are checks though, guys. We can't just throw this in our calculator unless your calculator has an absolute value feature on it. The ones I have in here don't. If they do, I cannot find it. I will keep searching, but at this point I have not found one. So this is something that we will have to step through a little bit. Be very careful. Absolute value bars are not parentheses. I can't distribute that negative 1/2 to that 4, no matter how much I want to. I have to do absolute value first. Absolute value of negative 4 is 4. Negative 1/2 times 4 is negative 2. Now, once you get to this part, if you need to do negative 1/2 times 4 in the calculator, hey, that's totally fine. Check the other side, so negative 1/2. Remember, absolute value first. And absolute value doesn't just mean I switch the sign. Absolute value is distance. So the absolute value of 4 is 4. Negative 1/2 times 4, again, gives us a negative 2. And that's what we need. Now, oftentimes at this point, sometimes I'll get the question, so do I need both of those answers? Yeah, you need both. Both of them work. When we solve an equation, we want to find every single solution we can. So every single value for x that will make that equation true, that will make the left equal the right. So these first 4, I kept the absolute value pretty basic. Number 1, all we did was move left. In the second one, all we did was move up. The third one, all we had was a stretch. The fourth one, we had a shrink and a reflection. So we saw all the basics in the first 4. Now let's crank it up with the last 2, and let's call it a day. Now, if you want to try working ahead of me on these, some of you might already have these finished on me, and that's fine. If you need to work through them piece by piece with me, totally cool. That's why we're practicing some more. Have the left side. Have the right side. I always start with the plain y equals. And by the time we're done with this unit, all of us should be fantastic at graphing equations that just have a y. Plain old y equals. When you go to graph the absolute value ones, you guys write out as much of this as you need to. For some of you, I know it helps to see it visually. I'm not going to give you all those little answer blanks. So if you need to write it out and label it, please do so. If you're comfortable enough to the point where like, nope, I can just look at that and graph that sucker, hey, go for it. All right, so that 2, it is bigger than 1, so it will tell me to stretch. It is also my slope. There's nothing happening inside the absolute value bars, so there's no left or right. The -3 is a down. Again, how much of that you write, maybe since this is your note sheet, might come in handy to label them. So our graph, it doesn't go left or right at all, but it does go down 3. And then we have a stretch of 2, so our slope is 2. Up 1, right 2. And we graph. What happened on this one? Do we intersect? Yeah, so we've got a no solution. Now remember, it's not just because it equals a negative over here. Number 4, the one we did right before this, equaled a negative, and it worked. We had solutions. So you cannot just automatically, oh, the y equals a negative. Nope, it's going to be one of those no solutions. Graph it and see. Because that negative is also affected by everything that happens over on the right side too. So when we had in question number, in question number 3, that left side was going to be a positive every time. We had a positive times a positive. But in question 4, we had a negative times a positive. We were going to get a negative. So just because there's a negative over here by itself does not mean no solution. We saw it a couple times where it did. We saw one time so far where it didn't. Let's see how number 6 works. Number 6, we've got a whole bunch of stuff going on here. I'm going to move my y equals down a little bit so I have room to label. Now again, we have our equation equal to a negative, but I can't just automatically jump to that and say it's going to be a no solution. In number 3 it was a no solution, but in number 4 it wasn't. Number 5 it was a no solution, but now number 6 it might not be. Number 6 has a lot going on. So here we go. We do have a negative sign. So we do reflect. So the negative sign is just the reflection. The negative sign is the reflection. The 2 is bigger than 1, so it tells me to stretch. So the negative sign is the reflection part. When it comes to the stretch shrink part, I just look at the number. Now the two together, I do have a slope of -2. If you want to put it over 1, you can. Some of you just have that habit right away, it goes over 1. It's a great habit to have. Alright, this one's got a whole bunch of stuff going on. We do have something happening inside those absolute value bars. This is the one we really have to slow down on. X minus 1, it really goes to the right. The +3, that addition outside the absolute value bars, that was our newest idea with graphing. And that one goes exactly how we think. Plus is positive, so it's going to go up. So a whole lot going on this one. To find my vertex, my starting point, we go right 1 and we go up 3. There it is. Right 1 and up 3. Then I use my slope. And I know some of you are thinking, oh, Miss Golly, I don't think they're going to meet. Sure they are. This one has a reflection. It's a negative slope. So we're going to go down 2 and right 1. Down 2 and right 1. It's going to take us a little longer to get there. Our 2 are a little bit further apart here. There we go. There we go. What do we got? -3, -5, and we've got 5, -5. We just need the x pieces. It's also especially important that you check, because some of us, I've noticed when we go to find those intersection points, some of us label the xy backwards. So if you're one of my people that you switch around the x and the y on your ordered pair, when you go to check your x values, they're not going to work, and then you'll catch your mistake. So be careful when you list your ordered pairs. Now the check on this one, it is going to take a little more work. -2, absolute value bar. -3 for the x. We've got +3. Alright, and we've got to do what's inside those bars first. -3 minus 1 is -4. Everything else, guys, leave the same. I know for some of us we don't want to have to keep writing out so much step by step by step, but that's what it takes for these. Then I have to actually find the absolute value next. Absolute value of -4 is 4. multiply next, and then we do our addition. Once you get your absolute value out of the way, so like at this point right here, if you want to put that in your calculator, you can, using your parentheses. And maybe some of your calculators, if you have one of your own, maybe some of them do have absolute value bars on them. So maybe that's something you look for. I have to do what's inside the absolute value bars first. I have to find absolute value next. I have to multiply next. And then I have to add. So checking, as always with solving equations, I know some of you just view it as I don't really have to do that. But it's a way you're going to know if you're right or not. I know a lot of you out there, you're getting very confident with graphing absolute value. I can tell it based on your quizzes that I've graded so far. But make sure, it's so easy. It's so easy to accidentally go left instead of right. So easy to do that. Or instead of going down 2 and right 1 for your slope, we accidentally go down 1 and right 2. It's so easy to do those little things. That's why it's so important we check. Do these checks take a little more time? Yeah, they do, because we don't have that absolute value shortcut on our calculators. So it's something that we have to do a little more computation ourselves for. But it's something we can all handle doing. So solving this way, I wanted to start solving this way so that we could use the skills we already have to solve an equation we never have before. We can graph these absolute value equations. Most of us are getting fantastic at that. So I'm hoping that by the end of the next couple days here, we're all super solid at graphing absolute value. The other reason why I wanted to graph these first, before we get into the algebraic piece of it, is so you could see when we solve these, they're not like the equations we solved at the beginning of the year, where we just always had x equals, and then we got one answer. We got one value. Now we have our absolute value. Every time we've been getting 2 values. Or we had a no solution a couple times. And those no solution ones, they can happen. They can definitely happen.